1991, unusually low ice exposed his remains. The discovery immediately triggered confusion. The body was found near the modern border between Austria and Italy, and early recovery efforts were rough. Workers used ice axes, drills, and other tools before the true age of the remains was understood. Once radiocarbon dating revealed that the man came from the Copper Age, everything changed. Ötzi was not simply a skeleton, he was a biological archive. His skin survived, his internal organs survived, his clothing and tools survived. Even material from his final meal survived inside his digestive system. Researchers could study an ancient European almost as if he had stepped out of his own time and fallen directly into ours. And for years, each investigation added another piece to the portrait. Analysis of pollen and plant material helped researchers trace his movement through different elevations. The food remains indicated that he ate shortly before he died. His final meals included meat from wild animals, cereals, and plant material. Later examination of his stomach identified a calorie-rich combination that included ibex meat and fat, exactly the kind of energy-dense food that could support a difficult mountain journey. His body contained the whipworm parasite. His teeth showed decay and gum disease. Genetic analysis suggested that he was lactose intolerant, which was common among European populations of his period. Researchers also detected a strain of Helicobacter pylori, the bacterium associated with stomach inflammation and ulcers. Then there was the copper axe. In Ötzi's world, copper was not an everyday material. Producing a blade required mining, smelting, craftsmanship, and access to trade networks. The axe may indicate status, specialized responsibility, or wealth, but the weapon also deepened the mystery. If Ötzi had been killed during a robbery, why had his attacker left such a valuable object behind? Perhaps the killer fled. Perhaps the axe had symbolic meaning. Perhaps the attack was personal rather than economic. Or perhaps the conditions surrounding his death were far more complicated than a single ambush. Evidence from one of Ötzi's hands revealed a deep cut that had begun healing before his death. The wound may have been caused during close combat several days earlier. That suggests the arrow attack might have been the final event in a longer conflict. Imagine the scene. A wounded man leaves a settlement or valley. He climbs upward. Perhaps he is escaping enemies. Perhaps he is returning home. Perhaps he is crossing the mountains for reasons that disappeared with everyone who knew him. Behind him, the lower valleys fade beneath cloud. Ahead, the landscape becomes colder and more exposed. Then an arrow strikes from behind. Ötzi falls. The mountain closes over him, and for 53 centuries his identity remains frozen beside his weapons. When scientists began decoding his genetics, DNA appeared to offer a way through the silence. Ancient DNA is not an ordinary sample. From the moment an organism dies, its genetic material begins breaking into smaller fragments. Heat, moisture, microbes, and chemical reactions damage the sequence. Researchers must also fight a modern enemy: contamination. A tiny amount of DNA from someone who touched a specimen can mix with the ancient genetic material. Archaeologists, rescue workers, museum staff, and laboratory technicians can all leave biological traces. And Ötzi had been handled before anyone understood what he was. In 2012, researchers published a genome sequence that transformed the investigation. The study indicated that Ötzi had brown eyes, blood type O, and genetic risk factors connected to cardiovascular disease. It also suggested that his ancestry contained genetic components associated with early European farmers, hunter-gatherers, and people linked to migrations from the Eurasian steppe. That final element appeared to place Ötzi inside one of the greatest population transformations in European history. Thousands of years ago, Europe was shaped by multiple waves of migration. The continent's earlier hunter-gatherer groups were joined by farmers whose distant ancestors came from Anatolia, the region that includes much of modern Turkey. These farming communities brought crops, livestock, permanent settlements, and new technologies into Europe. Later, groups carrying substantial ancestry connected to the Pontic-Caspian steppe expanded westward. Their movement changed Europe's genetic landscape and is often linked to major cultural and linguistic developments. The 2012 genome appeared to show that Ötzi already carried traces of this steppe-related ancestry. It seemed reasonable, but there was a chronological problem. The major expansion of steppe ancestry into much of Central and Western Europe occurred around Ötzi's era and continued afterward. If the result was accurate, the Iceman could have been evidence that this ancestry had already reached deep into the Alpine world. For more than a decade, that genetic portrait influenced how Ötzi was understood. Artists reconstructed him as a weathered, light, to moderately skinned Alpine man with long, untidy hair. Documentaries showed him moving through a familiar version of prehistoric Europe. Museum visitors looked into his reconstructed face and believed they were seeing an approximation of reality. But science rarely freezes as neatly as a body inside a glacier. While sequencing technology improved, databases of ancient genomes grew, Researchers gained better tools for identifying contamination and comparing prehistoric populations, and scientists began to suspect that the original genetic sample did not tell the whole story. The turning point came when a team from the Max Planck Institute for Evolutionary Anthropology and URAC Research returned to Ötzi's DNA. Instead of relying on the earlier low-coverage sequence, they produced a much more complete genome. The new sequence reached an average coverage of about 15, 3 times. In simple terms, scientists could read the same regions repeatedly, increasing confidence in the result. More importantly, the contamination level was far lower. The outcome was published in Cell Genomics in 2023, and almost immediately, one of the old conclusions vanished. The new study found no detectable step-related ancestry in Ötzi. The signal, identified in the earlier analysis, was most likely caused by contamination from modern DNA. This was not a minor technical correction. It changed where Ötzi belonged in Europe's human story. Instead of being a heavily mixed representative of multiple prehistoric populations, he appeared to come from a remarkably isolated alpine community. Approximately 2% of his ancestry was related to early farmers whose distant roots traced back to Anatolia. Only a small portion was connected to European hunter-gatherer ancestry. Among the known European individuals from his period, Ötzi carried one of the highest proportions of Anatolian farmer-related ancestry yet identified. This did not mean Ötzi himself came from modern Turkey. His ancestors had reached Europe many generations earlier. By the time Ötzi lived, farming communities had been established across parts of the continent for thousands of years. But his genome suggested that the population around him had experienced surprisingly little mixing with neighboring hunter-gatherer descended groups. The mountains may have acted like walls. Valleys only a short distance apart can become separate worlds when travel requires crossing high passes, snowfields, and dangerous ridges. Communities might exchange tools, animals, and marriage partners, but not always in equal numbers. Let's see. His ancestors may have lived within a small and genetically restricted alpine population, protected and trapped by the same geography that would eventually preserve his body. And then came the second shock. The genes connected to Ötzi's appearance did not match the face the public had known for decades. The new analysis? Landscape, farmers with Anatolian-related ancestry, descendants of hunter-gatherers, communities connected across trade routes, groups separated by mountains, rivers, and cultural boundaries, and soon, steppe-related populations whose expansion would transform much of the continent. As genetic world faded, his body survived, but the population structure surrounding him did not. Recent research on prehistoric individuals from the wider Tyrolean Alpine region has added another layer to this story. Ötzi shared broad ancestry with people living around his time, but yet some of his direct maternal and paternal lineages appear unusual. His maternal mitochondrial branch, known as K1F, has been exceptionally difficult to identify in other ancient or modern individuals. That may mean the lineage became extremely rare, or disappeared completely. Ancient DNA sampling remains limited, so absence from current databases cannot prove extinction with certainty. But the silence is striking. A maternal line that passed from mother to child across generations may have ended somewhere after Ötzi's lifetime. No monument marked its disappearance, no written record preserved its name. It simply faded from the genetic map. Feared strangers and crossed mountain passes. Ötzi's genome does not merely tell us where his distant ancestors came from. It reveals how much of his human world is gone. There is still a danger in turning every new scientific result into an extreme headline. DNA did not prove that everything known about Ötzi was false. His age remains broadly understood. His equipment is real. His wounds remain visible. His final meals still survive inside him. His connection to Copper Age, alpine communities, has not disappeared. The 2023 genome refined the portrait. It corrected contamination. It changed the estimate of his ancestry and likely appearance. Science did not fail because the earlier interpretation changed. Science worked because researchers returned with better evidence and allowed a famous story to be corrected. But one question remains unavoidable. How many other ancient faces have we reconstructed using assumptions that future evidence will overturn? Archaeological reconstruction sits between data and imagination. A skull can reveal the structure of a face. Genes may indicate probable pigmentation, eye color, and hair traits. Clothing tells us how people adapted to climate. Objects reveal technology and status. But the final image still requires interpretation. The first Ötzi reconstructions were not deliberate deception. They were products of the evidence available at the time. Yet once an image enters museums, books, and documentaries, it gains authority. People remember the face more easily than the uncertainty behind it. The new genome forces us to separate those two things. The Iceman was never the reconstruction. He was a real man whose appearance, identity, and choices were more complicated than any statue could capture. And there are still mysteries his DNA cannot solve. We do not know his name. We do not know the language he spoke. We do not know whether he was a leader, metalworker, farmer, trader, healer, or someone who moved between several roles. We do not know who shot him. We do not know whether his killer watched him fall. We do not know why the copper axe was left behind, and we do not know whether anyone searched the mountains for him. Perhaps his community believed he had vanished during a journey. Perhaps they knew exactly what had happened. Perhaps the person responsible returned to the valley and lived for decades carrying the truth. All that remains is the crime scene, a body, an arrow wound, equipment scattered near the ice, and genetic evidence that continues speaking long after every witness disappeared. Even Ötzi's body is not scientifically silent. In 2026, researchers reported a detailed study of the microbial communities associated with the mummy. They identified a complex mixture, microorganisms connected to his ancient gut, cold-adapted species linked to the glacier environment, and modern microbes introduced during decades of conservation. Some cold-resistant yeasts remained metabolically active under laboratory conditions. The finding does not mean Ötzi himself is alive. It means his preserved remains are still an ecosystem, one shaped by life, death, ice, and modern museum care. That discovery creates a new challenge. Every examination can reveal information, but every intervention can also change the object being studied. The chamber in Bolzano, where Ötzi is stored, recreates glacial conditions. His body is kept at approximately -6 degrees Celsius with carefully controlled humidity. Visitors see him through a small window. Behind the wall, sensors and preservation systems work constantly. The goal is to keep his tissues stable for future generations of researchers. Because the most important technology for studying Ötzi may not exist yet. 30 years ago, scientists could not produce the genome available today. Future tools may recover chemical traces now invisible. They may identify where he spent his childhood with greater precision. They may reveal more about the people around him. They may even narrow the circumstances of his death. But no technology can restore the full person. DNA can estimate ancestry. It cannot preserve memory. It can suggest baldness. It cannot tell us how he felt about growing older. It can reveal disease risk. Or it cannot tell us whom he loved. It can connect him to ancient farmers. It cannot explain why he climbed the mountain on his final day. That gap between scientific power and human silence is what makes Ötzi so haunting. He is one of the most examined individuals in history, and yet, in the ways that matter most, he remains a stranger. For decades, the public imagined him as a long-haired, lighter-skinned alpine hunter shaped by a blend of prehistoric populations. The cleaner genome revealed a different man, darker, probably balding, overwhelmingly descended from early Anatolian-related farmers. Ötzi is not a solved mystery. He's a warning against certainty. Every generation has looked at the Iceman and seen something different. The hikers saw a dead climber. The rescuers saw a recovery operation. Archaeologists saw a Copper Age time capsule. Forensic experts saw a murder victim. Geneticists saw ancestry, disease, and migration. Microbiologists now see an ancient and modern ecosystem existing within the same preserved remains. And beneath all those versions is the original man. The one person who knew the entire story and took it with him beneath the ice. 5,000 years passed before the mountain released his body. Another 30 passed before cleaner DNA began releasing his true appearance. The next discovery may alter the portrait again. And when it does, the question will not simply be who Ötzi was. It will be far more unsettling. How much of what we believe about the ancient human past is history? And how much is only the clearest reconstruction our current technology allows us to see? September 19th, 1991. High in the Ötztal Alps, two hikers noticed something dark rising from the melting ice. At first, they thought it was the body of a modern climber. Then, rescuers began cutting it free. A shoulder appeared, a damaged skull, leather clothing, a strange copper axe. And within days, scientists realized they were not looking at an ordinary accident victim. They were staring at a man who had been dead for more than 5,000 years. He became known as Ötzi, the Iceman. For the next 3 decades, researchers examined almost every surviving part of him. His bones, his stomach, his teeth, his tattoos, his weapons, even the final food trapped inside his body. They reconstructed his face and traced his ancestry, or at least they thought they did. Because hidden inside Ötzi's ancient cells was a problem. The first major genetic portrait of the Iceman had been contaminated by modern human DNA. And when scientists finally produced a cleaner, higher quality genome, the familiar image of Ötzi began to collapse. He was not descended from the populations researchers expected. He probably did not look like the famous museum reconstructions. And the isolation written into his DNA revealed something even larger, a forgotten human world hidden behind the mountains of prehistoric Europe. So who was the man beneath the ice? And why did it take 30 years for his own DNA to correct the story told about him? The answer begins not in a laboratory, but inside one of the most dangerous landscapes in Europe. More than 5,000 years ago, a man climbed into the Alps. The year was somewhere between 3350 and 3120 BCE, during Europe's Copper Age. Egypt's Great Pyramids had not yet been built. Stonehenge was still centuries away from its final form. Across Europe, farming communities lived in scattered valleys and settlements. Metal tools were rare. Travel was slow. Survival depended on land, livestock, family networks, and knowledge passed down through generations. Ötzi entered this world as an ordinary human being, but the equipment found beside him suggests that he was not powerless. He carried a valuable copper axe with a polished blade. He had a longbow that was not yet finished. A quiver held arrows in different stages of preparation. He wore layers made from animal skins, grass, and leather. His shoes were engineered for rough mountain ground, with insulation designed to protect his feet from freezing temperatures. He also carried a small toolkit, a flint dagger, a pressure flaker for sharpening stone blades, containers made from birch bark, pieces of medicinal fungus. Everything around him created the image of a man who understood his environment. Yet when scientists examined his body, they found signs that his final journey had not been peaceful. Ötzi was approximately 45 years old, an advanced age in his time. His teeth were heavily worn, his joints showed strain, his arteries contained calcium deposits. His body carried dozens of tattoos, many positioned near areas affected by physical wear or pain, but none of those conditions killed him. An arrowhead was buried in his left shoulder. The projectile had torn through a major artery. He also suffered trauma to his head. Blood loss from the arrow wound is widely regarded as the most likely cause of death. Although researchers continue to debate the exact sequence of his final moments, someone had attacked him. And that attack transformed a prehistoric traveler into one of archaeology's most famous murder victims. But there was another mystery. Why was his body preserved at all? Normally, a person dying in the open would quickly be destroyed by weather, animals, bacteria, and decay. Ötzi's fate was different. Soon after death, his body was protected by snow and ice. The high-altitude environment slowed decomposition. At some stage, he settled into a shallow, rocky depression where moving glacier ice did not completely crush him. For thousands of years, the mountains sealed him inside a natural freezer. Then, in